Hitting an asteroid is not what you imagine. An asteroid impact doesn't work like two billiard balls hitting each other. Hitting an asteroid like NASA's DART mission is a little more complicated, even if you ignore the difficulty of launching a blazing fast spacecraft into a very, very tiny body an unimaginably far distance away. Asteroids are not like rocks. Well, some are exactly like rocks, but most of the bigger ones share more in common with a bucket of gravel than a single stone. Many are a collection of sand, dust, pebbles, boulders, all held very loosely together by their own meager gravity taking the place of the bucket. If you were able to transport Dimorphos, the asteroid hit by the DART impactor, to the surface of the Earth, you likely wouldn't have a cool asteroid to look at, but rather a giant, sad heap of weird gravel and boulders. Asteroids vary far too much to know for certain, however. Some are very dense and others are very porous. This and the fact that asteroids can be very small and very far away means we don't exactly know the properties of many known asteroids and therefore have no idea how they would behave if we, for example, slam a probe into them at 14,000 miles an hour. It's likely that Dimorphos could change speed somewhat, but how much isn't known. Its exact mass is somewhat of a mystery, and the density and makeup of the asteroid will affect how much momentum is transferred to it from the impactor. A debris cloud was seen blasting away from the impact, but the force was not sufficient to blow it up completely. That isn't the point. Even if we find an asteroid on a collision course with Earth, a gentle nudge a few years in advance would be the difference between a direct hit and a miss. Blowing it up would just mean we have a million smaller asteroids to worry about instead of just one.